Okay, this is a review for the fractions test, the rational functions test. Fraction functions. They look like this. That's an example of one. Would you please? Okay, I'm back with you. I want you to take this function and I want you to find the domain, the vertical asymptotes, the horizontal asymptotes, which by the way, Bob tells you those. And hopefully I've taught you a couple dumb little words to remember if I give you x equals something, whether or not you're going to know that's a vertical versus a horizontal. I gave you little ways to remember that. All right. Anyway, the last thing is the whole. So there's, hopefully you're not going to by accident put the x equals things here under the horizontal asymptotes. That's a really common mistake. Be careful with that. I gave you that vertical and what's the other word? Horizontal, to help you remember which one's which. All right, try this one. This is review day, so you should be able to do these. I'm going to pause for a minute while you give it a try, and then I will show you how it should have been done. So here we go. Domain. First of all, I got to factor it. X plus 1, x minus 1. There's a little too much chatting going on the back left side of the room. From my perspective, left. X plus 2. Okay, that and that cancel. So now I've got a hole in the graph. Y equals x minus 1 over x plus 2. You can't tell the hole by looking at this. That's why you need to find the hole ahead of time. All right? And then once I know that negative 1 is a weakness for this function at a hole, it's one part of the domain. All reals except x cannot be negative 1. That creates the hole. And x cannot be negative 2. And if this is the hole, then that is the what? Asymptote. That's one of the main things you got to get across to yourself, is if these things crash your function, that's why they're limits to the domain, then those things are either holes or asymptotes. And this is a hole, so that makes this the asymptote. And which asymptote? It's an x one. If it's an x asymptote, it's the vertical kind. Vertical asymptote is x equals negative 2. The hole is at negative 1, but I don't just stop there. I tell where the hole would be. And that's probably the number one thing that kids get messed up on is, in fact, I even had a kid ask me for a separate video on showing how to make a hole. I'm going to do that right here. This negative 1 goes into the resulting function. Negative 1 I know is the thing that makes the hole because of this. All right, so now that I know negative 1's the x of it, negative 1 goes in right here and right here. And now I have negative 2 over positive 1. Negative 2 over positive 1 makes negative 2. So this hole is at negative 1 comma negative 2. How many of you had that one right? Wow, almost the whole class. Nice job. Now the horizontals. The horizontals are the ones that Bob tells you about. There's 3 rules: Bob, Sob, and Bot. If it's a Bob, it's y equals 0. And this isn't close now, because this comes up on your Schoology quiz that you're going to take in a few minutes. Bob, y equals 0. This is not a Bob right here. This happens to be a same on both in this case. But if it was a Bob, bigger on the bottom, that's a typical fraction function, like this. That's a Bob. But if you put a plus 3 out here, doesn't it move the whole thing up 3? Therefore, wouldn't the horizontal asymptote also move up 3? So if this is a bigger on bottom, don't just assume it's automatically y equals 0. It starts at that, but then if you move it here, it turns into that. 0 plus whatever's on the outside. Okay, so this asymptote for this little function right here would have been normally y equals 0, but now it's y equals 3 because it's moved up 3. Okay, that's an example of a Bob. Here's an example of a Bot, bigger on top. That means like x squared plus 3 over x. The kind that are bigger on the top, they don't have asymptotes. They don't have at least horizontal asymptotes. So you say no bots, kind of like robots. And that reminds me in the fact I read in the newspaper the other day. That's actually just a prediction, so it's not really a fact. But the prediction was that 20 years from now, 1/3 of all jobs in the United States will be performed by robots. That's a big change that you guys get to witness as you are growing up and getting out into the work world. Like there'll be lots and lots, more and more and more robots running around. Now, we're not talking like sentient ones that can like, do your homework for you. We're talking about ones that are just getting more and more mobile and capable. Like right now in hospitals, they have figured out that the number one thing they can do to like decrease deaths in the hospital is to be really careful with medications. Because if they give you the wrong medication at the wrong time, it'll kill you. Like literally, all it takes is a nurse to go, oops, I gave you the white pills instead of the green ones that Mr. Johnson next door was supposed to have, and poof, you could be dead that fast. So they're having robots do this because robots aren't, distracted or having a bad day or whatever. So the robot takes a facial recognition scan of you and then knows it's for sure you, and then it pops out the little pills that you for sure need, and then it gives them to you. Now, could somebody still program the robot incorrectly? Yes. If the nurse types in the wrong medications for your face, it still could get you. But the point is, robots are becoming a bigger and bigger part, and you're going to see that throughout your life. That was just a 2-second little thing I read and thought was very interesting, especially about replacing humans with robots. So anyway, if it's a bigger on top, there's no asymptotes. So I say no bots. And the last part is bot and sob. Same on both, and that's y equals 0. No, it's not. Y equals ratio. Sorry. Same on both are a ratio. A ratio of what? The lead coefficients. What's the lead coefficient on that one? Say it. 1. And on this one? And so therefore it's 1 over 1, so it's y equals 1. That's the horizontal asymptote for that one, because it was the same on both. It was a ratio. Yes?
I'm slightly confused as how the y equals 1 over x plus 3, how it would be bigger on bottom.
All right, because the question was on this, why was it bigger on the bottom? Because the degree on the bottom is 1. If there is no x on the top, then it doesn't have a degree of 1. It has a degree of 0. So if there's no x, it's kind of like there's an x to the 0 there. And that means x to the 0, by the way, is equal to 1. So that would work. And x to the 0 would show you that it's degree 0. This has a degree that's bigger on the bottom. That's why it was a bob. All right. Now, that was one that is kind of your classic question. How many of you feel confident on that kind? All right. I probably don't need to do much more with that then. Next, let's talk about the kind where I give you some facts and you make an equation for me. Y equals 0 is one of this thing's asymptotes. It has another asymptote at x equals 2, and x equals negative 3, and x equals 4. It's got 3 of those x asymptotes. All right. Last thing is, it's a rational function with a whole at 7. I'm going to say x equals 7. Write me an equation that would work for that. Your answer, I'm not saying this is right. Looks something like that kind of an answer. It would have to have all these asymptotes, and hopefully you can tell which ones are horizontals and which ones are verticals. And your answer will kind of look like this when you're all done. Except that's not the right answer. Okay? I'm going to pause for a second while you give that one a try. Here's the way I would have attacked it this way. I would have said, all right, these are asymptotes, so they must be on the bottom. X minus 2, x plus 3, and x minus 4. Raise your hand if you had that part right. Okay, good. Next thing, if this is the asymptote, then could it be a bot bigger on top? No, because bots have no asymptotes, so that can't be it. Probably a same on both? No, then the ratio can't be 0. That wouldn't make sense. So then if it can't be those two, it must be a bob. So that means it has to be bigger on the bottom. And that means, looks like there already is pretty big on the bottom. It's degree 3 on the bottom. So what should I put on the top? Well, it needs a whole at x equals 7, so I could put an x minus 7 and an x minus 7 on the top and the bottom. Is it still bigger on the bottom? Yep. And now I've got this hole here and this one and this one that will cancel each other. All right, there's your answer for a rational equation that would fit all those things. All right, next kind. I want to give you a graph, and I want you to see how to write the equation for this. Okay, so here is a typical situation. You've got asymptotes put in, let's say there, and now it's graph that's going through that spot and this spot, and it's got a hole. I'll say that the hole is right there at 1, 2, 3, 4, 5. There's a hole in the graph at x equals 5. Write me the equation that would have to be. Pause while you work on that one. All right, here's how you do this one. I would be thinking, don't look at the hole, don't look at the hole, don't look at the hole. It's easier if you just write the equation for it without the hole first. Okay, so did I teach you that in soccer? Don't look at the goalie. Okay, if you're if you're kicking, the most common place for somebody to kick it is at the goalie by accident, and that's that's obviously because you're kind of focused on where's the goalie, and you end up kicking at the goalie. So you want to avoid looking at this hole because it screws you up, makes it much more difficult. If there was no hole, the equation would just be 1 over x, except it got moved to the right 2 and up 3. That's really easy, right? To me, that's pretty easy. And then that has a hole. It has a hole where? At 5, which is x is 5. So if I put an x minus 5 on the top, I need an x minus 5 on the bottom, and there's the most common mistake right there. What's wrong? No parentheses. Yes, I need parentheses around here because otherwise it wouldn't be allowed to cancel like this. Why couldn't I cancel if I didn't have those parentheses? Because now it's a subtract problem. And you can't cancel off like, 5 over x minus 5. I can't cancel those two 5s now because it's a subtract problem. But if it was a multiply problem, then I could cancel those 5s. But anyway, moral of the story, I need parentheses right there. And now it's a right answer. Yes, sir? 1 times anything just makes it disappear, so that 1 is optional. Yes? Up 2 people. Leto. Why is the x minus 2 on the bottom? Because it would have just been a normal 1 over x if I just started with a plain parent function. Would you agree that that's how they start? And this one got moved 2 to the right. Do you agree that the asymptote lines moved 2 to the right? How do I show 2 to the right? By going minus 2 next to the variable. That's how I get it to move 2 to the right. That's why. Any other parts? Okay, so we've covered the main things that you need to know for this next test. And what I'd recommend that you do is do the rest of the worksheet, the review worksheet that I assigned the other day. Check it really thoroughly. And in class today, we are going to do a little rationals, which is what this is, quiz. It's for day 2. So if you look back a day, it may even be back 2 days. The folder that's for day 2 of this unit has a Schoology quiz in it. Get that thing done, and this is about learning how to do it. Don't come up and say, but I got mine wrong because I had a parentheses around my x. I don't care if you get it wrong based on that. What you need to know, it's not going to go in the grade book other than you completed it. I just want to make sure you do this for practice and you learn from it. So if it marks you wrong for stupid little things, don't worry about it. Worry about it if you don't get how to do the problem. Okay, so you can come up and ask me questions during the Schoology quiz too. Okay, that's all I have for you for today.